My name is Keshwani. That's Keshwani. Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. This book contains 230 problem solving questions. It has 174 data sufficiency questions. We've already solved every single one of these problems. If you're interested in watching any one of the original solutions, you will find the original solutions from day number 1 through 250. Right now we are in the middle of redoing the problem, and we are on page number 278, I believe. Page number 278. Please turn to it. The problem that we are about to do is number 42. Number 42. Is the sheet of glass going to cover the tabletop? Very straightforward, very simple question. Is the sheet of glass going to cover the tabletop? And that is all that they're asking. And we have to be able to tell them either yes or no based on the data that is given to us in the two statements. Let's see what they tell us in the statements. In the first statement that they tell us, that the tabletop is 36 by 60. Well, obviously, knowing the tabletop is important. We need to know what the dimensions of tabletops are, but we also need to know something about the glass before we can say whether or not the sheet of glass is going to cover the tabletop. We need to know not only about the tabletop, the dimensions of the tabletop, but we also need to know something about the sheet of glass. They tell us nothing at all about the glass. The first statement by itself is not enough. It's not enough. A, D, B, C, E. A, D, B, C, E. If you still do not know what I'm doing here when I write down A, D, B, C, E, it's important that you watch this video. Just type in data sufficiency intro along with my name, Keshwani. Look for that video and watch that video in its entirety, and make sure you understand how to set up these problems, which is the most important step, the most important element in being able to do well on data sufficiency. You must understand what these answers mean, and you must understand how to tackle them in a systematic, organized, logical fashion. A, D, B, C, E. I'm not going to go over the whole process obviously right now, but I'm going to leave it up to you to watch it if you have not done so already. We just established that the first statement is not enough. That tells us that the answer cannot be A or D. Let's look at the second statement. The second statement tells us that the area of the glass, we are told, is 2400. Again, just knowing something about the area of the glass by itself is not enough. It's not enough by itself. Which tells us that the answer also cannot be B. 2 by itself is not enough. 2 is not enough. Now when we say not enough, it's understood that what we mean is that 2 by itself is not enough. The third step in the process is to put the two together. Let's put them together and see what happens. If we put two of them together, this is the part where you have to slow down and take your time, because otherwise they're going to get you. Now your temptation at this point, listen very carefully, your temptation might be to simply compare the dimensions here, 36 by 60 versus 2400, and you might be tempted to say that I see 2400 here, I see 60 here. If you would divide 60 but from both sides, this becomes 40. We're comparing 40 versus 60, and you might be tempted to say that 2400 is more than enough to cover the tabletop, in which case you will say that putting them together is sufficient. Or if you feel that you're being clever, if you think that you're being clever, you might say, well, is the tabletop going to cover the glass? And if you read the book properly, because I always put the most abridged version on the blackboard, the question, what it says in the question is that the tabletop, I'm going to read it verbatim here, it says so that this covers the entire tabletop and its edges are parallel to the edges of the tabletop. In other words, what they want is the glass to cover the tabletop so that the edge of the glass is parallel to the edge of the table. It has to cover entirely properly. Here, you might be able to say, well, this is not going to happen here because we have more glass than what we need here, and therefore the answer is no. Is the sheet of glass going to cover the tabletop? The answer is no, because it's going to hang outside, and you're going to say the answer is no, and based on because you're able to tell me yes or no, you might be again tempted to say that the answer is C. You might be tempted to say that because it's going to hang out. Where they're going to get you is this part. Listen to me very carefully. We do know that the area of the glass is 24, but we do not know the dimensions of the glass. We do not know the dimensions of the glass. They tell us that the area of the glass is 2400, but you do not know what it looks like. I'm not going to put it there. All we know is that it's 2400. All we are told is that the area of the glass is 2400. For all we know, the glass could very well be 1 by 2400. The glass could very well be 1 inch in width and 2400 inches long. That would be a damn silly thing to have. It could even be 1/10 of an inch. It could be also, I'm just being silly now, obviously. It's only when you're trying to be dramatic that's when it ends up taking longer to write it. Now, of course, I'm being silly here. I'm just being dramatic here. For all we know, it could be a glass which a width of only 1/10 of an inch, and it goes on for 24,000 inches. That glass of sheet is not going to cover the tabletop. So even putting the two together gets us nowhere, because all we know are the dimensions of the tabletop. Unless we know the dimensions of the glass exactly, we cannot tell whether or not it's going to cover the tabletop precisely because of the way it's phrased. It has to be, the edge of the glass has to cover, has to be parallel to the whole thing. The answer is D. The answer is E rather. The answer is E. Putting the two together does not get us anywhere. Answer is not C. Answer is not C. Let's move on to the next one. C is the most popular wrong answer here. Answer is not C. 43. In 43 we are told that P1 and P2, are populations of town 1 and town 2. So we have two towns and we are told that their respective populations are P1 and P2. We are also told that R1 and R2 are the number of reps. Representatives, R1 and R2 are representatives respectively from town 1 and town 2. Are you with me so far? Let's see what they're asking. What they're asking here is this ratio, is the P1 over R1 greater than P2 over R2? Is P1 over P2, is this ratio greater than this ratio? And then here we simply have to be able to say either a yes or a no. It doesn't matter whether the answer at the end turns out to be affirmative or whether the answer turns out to be negative. We just have to be able to give a definite answer, a definitive answer, either a yes or a no, either an affirmative or negative. And because of that fact, if you don't like looking at it this way, I don't like looking at it this way, because this is not how we usually speak in terms of population. So I don't like it. I'm going to write it like this. Which is the same exact question. Is the number of representative per 1000, is the number of representative per 1000 for town 1 less than the number of representative per 1000 for town 2? That's what they're asking for. Let's see what they tell us. They have to tell us something, obviously. Statement 1 tells us that the P2 is greater than, or rather P1. They tell us that P1 is greater than P2. Well, simply knowing that the town 1 has more people than town 2 does not tell us if town 1 actually has more representative per 1000 population. It's not enough. It's not worthless information. The information is not worthless, but it's not enough. A, D, B, C, E. Again, we just established that the statement 1 is not enough. Therefore, we know now that the answer cannot be A or D. The statement number 2 tells us that R2 is greater than R1. What statement number 2 tells us is that the town 2 has more representative than town 1 does. But by itself, all we know here is that town 2 has more representative. We know nothing at all about the respective populations of the two towns. Again, second statement by itself does not do any good. Second statement by itself is not going to do us any good. When we put them together, aha, now we get somewhere. Now we get here. If we put them together, what this tells us is that not only town 2 has less population, but it has more representative. Town 2 has fewer people, but more representative. If you put them together, it says that town 2 has fewer people because town 2, fewer people, more people, it doesn't matter. Town 2 has, yes, town 2 has fewer people. P1 is more than P2. Town 2 has fewer people, but has more representative. But has more reps. Well, if it has fewer people and more representative, then obviously the number of representative per 1,000 is of course going to be more for town 2 than it is for town 1 because it has more representative but fewer people. So putting them together, of course, it does get us anywhere. We are able to say either yes or a no. The question here was, is this ratio less than that one? The answer is yes, because town 2 does have more representative for a small amount of population. The answer is C. Let's move on to the next one. Number 44. Number 44. Oh, that's the last one in the column. Last one in the column. We have random sample rather. Not be fun to have random people. Random sample of 80 people. We have taken a random sample of 80 people, and the question simply is how many of these people are college graduate? How many of these people are college graduates? And we're going to put down letter G. We're going to put down letter G for college graduate. Letter N, we're going to use letter N in our discussion to represent not graduate, people who did not graduate from college. So let's find out. Let's find out what they tell us. In order for us to be able to answer this question, how many of them are college graduate in the survey of 80 people, we need to know something about the survey. We need to know a little bit more about it. Let's see what we can find out. The first statement tells us that not college graduate is equal to 3 times the number of grad. The first statement tells us that in the sample, the number of adults who are not college graduate is 3 times the number of graduate. Well, if we were to write this in equation, the not college graduate using letter N is 3 times G. Question is this information enough for us to be able to answer the question, how many of them are not college graduate? And the answer to that question is a resounding yes. Why? Because here's your first equation. They tell us that the total number of people who were surveyed was 80. And every one of them obviously is going to be either a graduate or not a graduate, which means N plus G is 80. This is our first equation. Here is our first equation, here is our second equation. We have 2 independent equations. Of course, we are able to solve for the 2 unknowns. The first statement by itself does the job quite beautifully. A, D, B, C, E. That tells us that the answer cannot be B, C, or E. Now we're going to look at second statement If it turns out that the second statement is also sufficient by itself, then the answer will be D. If it turns out the second statement by itself does not do anything, then the answer will remain A. Before we go to the next statement, let's do something here. Let's waste our time, okay? Let's squander our time, something that we will never do in the real exam. It will be a sheer waste of time because it's not necessary. Nobody's asking us how many college graduates there are. Nobody's asking us how many college graduates there are in the sample. That is not the question. The question is, can we figure out from the data that is given, do we have sufficient data? To which the answer is yes, we do have sufficient data. The part that we are about to do is just for learning purposes, just for the hell of it. It's very simple. It's very, very simple. N equals 3G, put it in here. 3G plus G equals 4G, G equals 20. What the hell? This is too simple. I was making a fuss about nothing. G equals 20. Number of college graduates is 20. I thought it was going to take a few seconds, but it was too simple. It was too silly. Let's look at second statement. I made too much out of it. I didn't realize it was that simple. In the second statement, they tell us that not college graduate is 40 more than the number of college graduates. There you go. There is another equation. There is another equation. Where is my stick? I cannot speak unless I have a stick in my hand. Not college graduate, which is what we are saying. N is whatever the number of college graduates there is, and it's 40 more. Well, there you go. There is your second equation, and there is our first equation in our survey. The total is 80. N plus G is 80, and N we are told is G plus 40. Well, there you go. Two independent equations, two unknown. It can very easily be solved. The answer is D. Second statement by itself also turns out to be sufficient. Therefore, each of these statements independently can do the job. Answer is D. And of course, this is also very simple. N equals G plus 40. We put it in here. N equals G plus 40. So what we're going to end up here, if we put G plus 40 here, so we'll end up with G plus 40 plus G equals 80. And 40 is going to cancel out with 40, and 2G equals 40, and G equals 20. The reason I'm doing this thing is to again remind you one more time, as I always do, to make sure this is, if you take a couple of seconds to actually do it out, even though this is not necessary in the exam, but if you happen to do that because it's too simple and it only takes 2 seconds, this is actually your insurance. The fact that G equals 20 here and G was equal to 20 here, that's your assurance that you've done the right work, because they never ever contradict each other. If you found out there were 20 graduates in the sample from the first statement, and the second statement, when you do the work and you find out that the number of graduates from the second statement turns out to be 25 or 30 or something other than 20, then something has gone wrong. You have done something wrong either in the first statement in your work or in the second statement. But they never contradict each other. You understand? They always substantiate each other. They always confirm each other. I'll see you tomorrow, okay? I'm not going to start the next page right now. Okay? Bye now.